Hello everyone, I'm teacher Winnie. Today we will discuss on Physics SPM Trial 2021 Kedah paper 2. Look at the first question. The first question is from Form 4 Forces and Motion 2.2 Motion Graph. Diagram 1 shows velocity against time graph for a moving motorcycle. So every time when you all do the question under motion graph, you all must be very careful about the y-axis. So for this question, your y-axis is velocity. You also have another two more graph, which is displacement time graph and also acceleration time graph. Okay, so whenever you do question involving graph, you do not just look at the shape and then try to figure out what is the meaning or how the motion of an object. It is good that you always relate it with gradient. Later on, the questions also will ask you regarding what is the physical quantity. So basically, gradient is the idea of y-axis divided by x-axis. Explain the idea first. Y over x. So in this question, in this context, velocity time graph, gradient is actually velocity divided by time, whereby velocity divided by time is what? Acceleration. But let's say this graph is actually displacement time graph. So they also have a line gradient. Okay, so how do you link the gradient now? Gradient is actually now displacement over time. And displacement over time is actually velocity. Yeah, so you all must be very careful with the y-axis, right? So let's see the first questions. A, underline the correct definition of velocity. So I just tell you also from this displacement time graph. Also generally this velocity is actually the rate of change of displacement. Rate of change means divide by time, right? So it's same lah, or something divided by time. Every time you see rate of change of something, then it's referred to those quantity. So like this case, displacement is velocity. Let's say you have rate of change of distance, then it's referred to speed. Okay, so I hope that you also remember velocity is basically what quantity? Vector quantity, same like displacement, or both involving direction. If we have the idea of speed, speed is scalar, and speed is actually rate of change of distance. So do not confuse these two quantity lah. Then we see the next question. Based on the graph, tick the base quantity shown on the graph. So as you all know, base quantity, there's only 7. They are the most basic and they cannot be derived in other form. Okay, while you can also classify quantity as derived quantity. If you see any 2 or more base quantity, they combine through multiplication, division, or both operation, then you have another new quantity, then they are called derived. So of course, the base quantity here is referred to time. Okay, and then you have other example like what? Length, temperature, current, amount of substance, luminous intensity. Okay, and all this will be base quantity. But then in these questions, it's time. Okay, next part 2, name the physical quantity shown by the gradient of the graph. So just now I did show, right? The gradient is referred to what? Acceleration. Acceleration. And then lastly, the question on question B2 is a vector quantity. Give another example of vector quantity. So another example of vector quantity. Just now teacher also give you some idea already. What is vector quantity? Vector quantity is quantity which have both magnitude and direction. That means they have value, magnitude lah, and also direction. So most of the physical quantity in chapter 2, forces and motion, especially when you learn about linear motion, okay, like acceleration, force, all these, they are actually vector quantity because the direction involved. So that's why when you all do calculation, like when you all calculate momentum, impulsive force, all these, you must be careful about the direction. Yeah, so all this will be a proper answer lah. Force, momentum, displacement, velocity, all is acceptable. But you all don't write back acceleration because they already have in B2. Okay, question 2. Question 2 is from Form 5, Chapter 1, Forces in Equilibrium. Diagram 2 show an advertising board held by a light iron rod and wire to a vertical wall of a building. The iron rod is fixed horizontally. So first name the force F. So where is F? So F is located over here. So it's actually in a wire. It's like holding something, correct or not? So like a string wire when they used to hold something. So basically, the wire will actually have tension. So the force is called tension. Okay, next, draw the vertical component Fy of force F on the diagram. Okay, so under the idea of resolution of force, giving you a force with an angle like F in this context, you can actually resolve this force, or I normally use another term say split lah, but that is not so correct. The best word is resolution, resolve it, but it's some sort like split into Y component and also X component. So this is actually Fy, this is actually Fx. So every time you see a force with an angle, and then the arrowhead is following the direction of the given force. So this one you pull up, then it become Y. This one pull down, X, or I will say, you split like that. So this is the idea, but in this question, they only need Fy. So that's why we show Fy will do. So you have your answer already, 1 mark. Okay, then B, if the mass of the board is 50 kg and the weights of the iron and wire is ignored, calculate the value of force F. Okay, so how do you solve these questions? So generally, any object that is hanging, right? Basically, they are in equilibrium. That means they are in the state of at rest. At rest. Okay, so you need to know not only Fy is acting on this advertising board. The advertising board also have weight, right? So you have another force which acting downwards, and you call it as weight. And if you notice just now when teacher resolve this Fx, now this iron rod actually is they're having another force which is in this direction. So for your general concept understanding, what is the relationship of all these forces? So if you were to look at the vertical component, the concept is Fy should be equals to the weight of the advertising board. And then if you were to look at the horizontal component, the Fx and the one that I label with the red one, the force on the iron rod. So maybe I put it force on iron rod Fi. They should be equal in magnitude. So if the direction is opposite, right, when you add up, you will get 0. Similarly, Fy plus negative weight, so you will get 0 as well. But they should have same magnitude, means same value. Simple idea example, the Fy is just assumption only, so you have a better understanding. It's 10. That means your weight also have to be 10. But then because the direction is opposite, this is negative. So that's why you have 10 plus negative 10. Hence, your resultant force is 0, which is equilibrium idea. So whenever you solve those questions under forces in equilibrium, you can make the relationship equal. Okay, once you know that they are at rest or move at constant velocity. So now we focus on the vertical part will do. Okay, since we already know they have to be equal, but first step, you need to know what is actually Fy. Fy. Okay, so how do you know or how do you link the relationship of this Fy with F with this angle? So generally, I can shift this Fy over this, then it's actually become a right angle triangle. Then you actually use the trigonometry, so katua, to get the relationship lah. Okay, so I want to know what is my Fy. I have F, I have 30. So which trigo do you all use? Basically, you can use what? Sine, right? So sine theta equals to opposite over adjacent. hypotenuse. So, okay, your hypotenuse is F. So hence, you can have the relationship Fy equals to F sine theta. So this is how you get the relationship or resolve a force and get the idea. Or I always tell students, when you resolve the force, after you resolve the force, you look at the angle that nearer, like this 30, right? If 30 touch what component? Fx. So if those components are the angle that touch, then it's always cos. Then the other one automatically will be sine. So this is what I teach the student to easily get the relationship. It's either sine or cos. But the moment you're confused, you memang use right angle triangle, do back the trigo. So hence, you basically will have this F what? Sine 30. Okay. So just now teacher already tell you all what is the relationship between your Fy and weight. Okay, for your understanding, how do you calculate weight? Weight is actually mg. So in this context, your mass is actually 50. Now g, if they didn't mention, that's why you need to use 9.81 or 9.81. So we calculate out first. 50 times 9.81 is basically 490.5 Newton. So like I mentioned already, Fy have to be the same as W, or the relationship. Or in general, if you want to know the concept is basically Fy plus negative weight. The resultant is what? 0, because equilibrium, right? Therefore, you have Fy equals to W. Then now we have F sine 30 equals to what? 490.5. Then we want F what? So you use 490.5 divided by sine 30. So you will get 981 Newton. So this is how you solve the questions. Of course, B, there is a lot of method to get the answer O. So, okay, you can use the triangle method and so on, right? So teacher using this resolution and then solve it. Or you can draw to the actual scale to get the result, like you measure the length, all this, you redraw the right angle triangle, because you can actually draw the forces of triangle up for this context. Okay, moving on, question 3. Question 3 is from Form 4, Chapter 3, Gravitation. Diagram 3 show Earth-Moon system. The Moon orbit around the Earth once in 27.3 days, and the distance between the center of the Earth and Moon is 3.84 times 10 power 8 meter. Part 1. Determine the linear speed of the Moon. Okay, so what is the formula we use in this questions? So linear speed, actually they have two formula lah. One is the basic one. If you know the concept of speed equals to distance over time. So in this context, the Moon will surrounding the Moon in a circular way lah, right? So that's why if you know the circumference of the Moon surrounding the Earth, then you have this 2 pi r, then divide by time. So when the Moon go one cycle, we call it the time as period. So we divide by capital T. Or you have another formula which is you will involve the gravitational constant one, right? But then in this question, we don't use it, so we just focus on this. Okay, so once you know the formula use, then you just sub accordingly. 2 pi, you can get it from the calculator. You can use the pi 22 over 7, 3.142, or in the calculator, no problem. So the R given here is where, okay? Your R is this 3.84 times 10 power 8 meter. So they indeed are in SI unit, so you no need to worry, you just put. Then, but the time, are you going to put 27.3 days inside? Cannot, you have to change your period into second, because second is SI unit. So 27.3 days, you change to hour, you times 24, correct? Okay, then you change to minute, you times 60. You change to second, you times 60 again. You have to change into second, then only you sub into the equation. Any student that forgot to do this step, that means you will lose 1 marks because your final answer is wrong. Okay, hence you will actually get 2358720 seconds. Okay, so we sub everything inside. Then you're supposed to have 1023.04 meter per second. Okay, I also try to press calculator, see is there any mistake or not. 1022.9. $27.39, 24 times 60 times 60. Okay, if I use the pi in calculator, my value will be 1022.90. So that's why they will still accept. So normally in answer scheme, you all don't worry. There will be a range of the answer because they will take into account like if the student press 3.14 to half, 22.7, or in SPM they are more specifically, they will just tell you use pi as 22.7, something like that. So you all will have a more accurate answer. Okay. Next one. The moon orbit around the Earth once in 27.3 days, and distance between the center of the Earth and moon is, okay, this one is in 4. You need this in 4. So it's actually from A just now. So now A2, they want you to determine the gravitational force on the moon by the Earth. Okay, again, you actually can have another formula, but because this question, they didn't give your gravitational constant, the big G. So that's why you actually can use the centripetal force formula to solve this question. So what is the formula for the centripetal force? F equals to mv squared over R. Okay, now in SPM, you all have all the formula, but then they just really give you the symbol. They don't tell you this F is referred to what force. Okay, like is this referred to a centripetal force, universal gravitational force? So that's why you still need to really when you do revision, you study, kind of get some idea. Okay, centripetal force is some sort this pattern. So in case you not really can exactly remember the formula, but then you got the idea, okay, centripetal force have mass, have velocity, have radius. So you still know what formula to be used, or else even giving you the formula list, you can't really apply as well. Okay, so once you know, again, do you have the mass? This mass is referred to the one that orbiting, so it's not the mass of Earth. So that's why you have mass of moon, M here. Then V is what you calculated just now, the 1023 or 1022, that one, okay? And then the R will be again on the previous page, or here also given 3.84 times 10 power 81. So same thing, everything is SI unit, you just sub, and then you get the answer. Then you're supposed to get the answer in terms of Newton. Now, of course, this is from the answer scheme. It's good that you all use the 1023.04, or just now because teacher calculated one is what? 1022. Okay, we try to use that one because I use the pi in calculator. 1022.9. Yeah, so yeah, don't round off when you sub into the formula. So better you have a more accurate reading. So same thing, teacher will try to calculate. Okay, bear in mind the 1022.9, you have to square it, because a lot of time this is what the student make mistake, and you all have to try to press calculator also when you do revision all this, because sometimes students like, oh, I know the formula enough already lah, because you also need to know how to press calculator. Sometimes you all can get the formula already, but the problem is you all do know how to press calculator, or you didn't put bracket. Like whenever you divide anything below like this 3.84 times 10 power 8, right, you have to put bracket one if you use the division sign lah. But some calculator you all have the fraction form, then you will have less mistake. Okay. So I basically get, yeah, same lah, the final one. Okay. So about the final answer, 2 to 4 decimal point. So I can even write 2.0027 times 10 power 20. Remember, it's 10 power 20, and you must write the unit. No unit, it's wrong. Okay, lastly, B, the moon doesn't move closer to the earth even though the gravitational force act on it. Okay, so for your understanding, when the this is earth, when the moon, right, then they try to circulate the earth, correct? Basically, when they are moving that time, they will actually, why they are in a eclipse forms or close to circles. Okay, so because they have to be in a same constant speed. First, the speed is constant, the value. But then when they move that time, right, they will always have a tangent line in this way, like that. The value is same, but then direction, how, if you look at the arrow teacher draw, direction is always changes. Direction changes. Okay, but this one is causing the object keep on move in the circular manner lah. And as you know, they're supposed to subject to the centripetal force, and this centripetal force is also equivalent to the gravitational force. Okay, so they only change in terms of directions also, but that's why they got change in direction. That's why we can also say that they are having what? The gravitational force cause the centripetal acceleration change the moon velocity in terms of direction. So basically they only change in direction. Then the moon move in a circle at constant speed but do not move closer to the earth. And lastly, you say the centripetal force required is provided by the gravitational attraction of the earth. They are same, so that's why they won't move closer and closer to the earth. There is a force between the two objects that causing it constantly surrounding the earth only. Next question 4 is on the Form 5 topic, radioactive decay. A research conduct and investigations using phosphorus 32 to study the absorption and movement of fertilizer in the plant. Okay, and in the plant, and diagram 4 shows how radioisotopes phosphorus 32 is injected to the stem of the plant, and the half-life is 14 days and emit beta particles. First, they normally like to ask definition or instruction most of the time. The first one is under the concept of knowledge. So what is the meaning of half-life? So half-life is actually the time taken, correct? So the keyword time taken for half of the nucleus. You can replace the term nucleus or become activities of the material, radioactive material to decay. Half of the material or half of the activity to decay. So B, the initial activity is 800 counts per second. Calculate the time taken for the phosphorus activity to decrease to 50 count per second. Okay, so they already tell you the half-life is 14 days. 14 days. We will use this information one. So half-life, I write aside first. The T half is 14 days. But you need to know how many half-life have been undergo by this activity until it reach 50. So you can do a simple idea like this, arrowhead way. Teacher will tell student 800, half of it become what? 400. 400 become 200. 200 become what? 100. 100 become what? 50. So basically, the number of half-life here, you count how many T-half that I draw on top of the arrow. You count the number arrow, you're not counting the number, So there are 4 half-life, right? So the time taken is basically 4 half-life. Agree? Then you use 4 times 14, then you get the answer. Okay, so 4 times 14 is 56. And the unit is days, so you have to write. Or you can use a formula way, which is n equals to half bracket n and naught. Where this, you all need to know what is all this about. N naught is the initial counts. N is after decay. So that means this is 50 half n 800. So you rearrange 50 divided by 800 is how much? Okay, so it's basically 1/16, right? You simplify. Then later on, you make them equal left and right. So 1/2 power of 4, right, equals to 1/2 n. So this little n is number of half-life. So again, you get n equals to 4. Then you fall back to this one. So you can use this way 2 marks, or this arrowhead way of 1 mark, 2 marks. Okay, so hopefully you all know how to calculate already. Next, a small pond nearby a nuclear reactor become contaminated by the release of radioactive waste, and the radioactive of sample of the contaminated water from the pond is tested for 5 minutes, and the result is shown in the graph. So this is basically a decay curve. Okay, so what they actually want you to find, they say use a graph to find the half-life of the material of sample, and then show on the graph. That's why I got 2 marks. So from the graph, how do you get the half-life? Okay, so you basically do interpolation. Interpolation means you draw the vertical line, the horizontal line idea. So from 400, 800, half of it is 400, right? 800, half of it is 400. So you can draw dotted line or just clear line, then you move down. Okay, then you need to know how to read. So basically, 5 little box is 0.5. That means one small box is actually 0.1. Also, you have second box mark 1.2. And then you also need to write the unit of minutes. So the answer is 1.2 minutes. Now, the radioactive source does not pose a danger if it has decayed to 1/8 of its original radioactive. Calculate the time taken. So now they give you in terms of fraction. I always tell students for fractions, a full fraction is what number? Full fraction will be 1, correct? Before you cut into smaller pieces, right? So the arrow way is you from 1, you half of it, become 1/2, become 1/4, then become what? 1/8, right? So again, how many half-life you undergo? 1, 2, 3, right? So 3 times 1.2, then you get the answer. 3.6 minutes. Or if calculation way, this is the way. This one, they didn't use the arrow one. So what means the final step, you still do the same thing. You use arrow one will be like that. Sorry. 1 become 1/2, become 1/4, become 1/8. So there is 1 time of half-life, 2 times, and 3 times. So your final idea is to get these 3. Or calculations, this one is the n, and this is n naught. N naught means initial amount 800. Or in terms of fraction, you can put 1 and then this one 1.8 as well. Nothing wrong, okay? You will still get 3. Okay, next part. If the sample of contaminated water used in the test is of a smaller quantity, what happened to the value of the half-life? Okay, so they will be unchanged as well, because this radioactive decay, they are random one. So that's why they are not affected by amount, temperature, all this. Number 5, diagram 5.1 show 4 pendulum bobs of different length tied to a string. So this is under Form 4 concept on this resonance, concept on the resonance. So you have this setup called baton pendulum. Then you have X as the driver. That means you will swing X, and then A, B, C will move together. Okay, if you all do this activity in school, you're supposed to know that among these 3 pendulum, right, they have different length. But then one of it, after some time, they will swing at same oscillation with this X, and then with high or maximum amplitude as well. So you all remember which pendulum? It is actually pendulum B. How come B? Because they have same length. So this is the idea to demonstrate the concept of resonance. This is how they show the concept of resonance, because same length also means same natural frequency. Okay, so we see what is the requirement of the question first. Pendulum X is displaced and released without touching the other pendulum, and pendulum X oscillate with frequency of 2.0 Hz, and the other pendulums start to oscillate due to oscillations of X. What is the meaning of amplitude? Amplitude, you have any oscillating system initially at rest or at equilibrium, right? That means not moving. Then you will swing the highest. When you swing the highest, so this is called maximum displacement from equilibrium. Okay, then next, just now teacher already mentioned what is which one will oscillate at maximum amplitude, right? The one which same length, which is what? Pendulum B. So the reason you just need to say because the length of the bob pendulum is the same. Okay, they have the same length. Then you can know this is what we call it as resonance. So next, they want you to calculate the period of oscillation of pendulum X. Again, in the questions, they actually give you the frequency. Notice or not? The pendulum X oscillate with frequency. So how do you relate frequency with the period? The frequency given is 2 Hz. So the relationship is T equal to 1 over F. Period is the reciprocals of the frequency. So you just divide by 2 and then you get 0.5 second. E. Diagram 5.2 shows the Tacoma Bridge, United States of America, was collapsed in 1940 due to phenomenon stated in 5C. Based on the phenomenon, explain how was this tragedy happen. So basically, what happened during that time is there is a strong wind that actually blow on the bridge. So this strong wind actually, when they blow, they actually have this frequency or this strong wind, and we call this as a force frequency. They force the bridge to oscillate at the same natural frequency of the bridge. Okay, so again, when any object that encounter resonance, right, the particles inside the object, they will vibrate at maximum amplitude. So when this happens, that's why the bridge collapses. Okay, so you see the force frequency from the blowing wind I mentioned just now is equal to what? Natural frequency of the bridge. Natural frequency of the bridge. And therefore, the bridge vibrate at what? Maximum or very large amplitude. And eventually, they will collapse due to resonance. Now, other simple idea regarding resonance is like I always tell students, easy to remember one is the opera singer. Sometimes they sing with very high frequency, right, high pitch. Re, mi, fa, so, okay. So they're not any frequency can cause the glass to break, one, agree? Right? It's only certain frequency. So the frequency that cause the glass to break is the frequency of the glass itself, which we call the natural frequency. Natural frequency is the fundamental frequency where an object starts to vibrate or oscillate. So the moment the opera singer sing that pitch, not because loud enough, it must be the pitch, the do, re, mi, fa, so. Same as the natural frequency of the glass. Then what happened? The particle in the glass vibrate maximum, so that actually breaks. So it's similar idea like this incident also. Next, pendulum X will stop oscillating after a few minutes. So on diagram 5.3, sketch the displacement time graph to show the damping process. Damping means what? The decrease in amplitude due to loss of energy through frictions. So you will have this shape. So when you draw the graph, right, your amplitude amount is getting smaller and smaller. But bear in mind, your period, the x-axis, they have to be same. Or frequency remain the same or period. This part lah. Because sometimes students will draw this part getting smaller as well. No, this one must be same. Period or frequency same lah. Only the amplitude decreases. This one getting smaller and smaller and smaller and smaller if you want to continue. Okay. Number 6. Diagram 6.1 and 6.2 shows two similar cargo ships sailing on the ocean. And cargo ship A is without load and cargo ship B with load. Total weight of both cargo ship is different. What is the meaning of weight? So the simple definition for weight will be what? The gravitational force acting on an object. So weight is gravitational force acting on an object. That's why all of us will always what means attract. We are not like floating in the air. We always have a force acting downwards towards the earth. Okay, next one. By observing diagram 6.1, 6.2, compare the total weight. So based on the question, they already tell you all the total weight for both cargo ship is different. Okay, they are different. So if you observe them, obviously B have more load, right? Because there is so many load over here, right? So therefore, the weight of the cargo ship B is greater. You can use the symbol this greater, or you don't want to use the words ship B, ship A. You can also replace the idea, the weight of ship in diagram 6.1 is more than 6.2. Can. Okay, so all is acceptable. Then therefore, compare the volume of water display. So the volume of water display also same as the volume of the submerged part. So when the cargo ship B is heavy, of course they will submerge more or less. Submerge more, right? Okay. Of course the drawing here is not so clear. So which volume is greater? B1 or A? B lah. Makes sense. Means they will sink more ma. Yeah. So this volume of the submerged is also equals to the volume of water displaced. So same thing, B is greater. Then next, compare the buoyant force. Okay, so how do you get the idea of buoyant force for this context is both cargo ship generally they are actually floating. Agree? Floating means at rest. This means they seems not moving. Floating. So in this context, you will link with the concept of resultant force as well. So therefore, the buoyant force will be equals to the weight. So which one have greater weight? B. So B will have a higher buoyant force as well. So then next you write this, the buoyant force of B is greater than A. Then relate the relationship. So what is the relationship? The more the volume of water displaced, the more the buoyant force. Then part D, calculate the buoyant force acting on the cargo ship. The mass of cargo is 15.05 times 10 power 3. Of course, whenever you calculate buoyant force, there is a standard formula, right? Which is rho Vg, where rho is the density of fluid, V is the volume of object submerged, G is gravitational acceleration. So do they tell you the density of the fluid? No, right? Do they tell you the volume? No. But then just now, do you remember teacher said it's a ship? What is the relationship? They are floating. FB and weight, same. So in this case, they are using the idea of weight. So can you calculate the weight? W equals to mg. Can, because they give you the mass here. This is the reason. Because sometimes students, I don't have this info. How do I get an answer? Because you need to link with another concept where they are equilibrium. Okay, hence 15.05 times 10 power 13 times 9.81, you get 1.476 times 10 power 15 Newton. So in this question, we are using the idea buoyant force equals to what? The weight of the cargo ship. Lastly, E, what will happen to the cargo ship B at River Bay? Give one reason for your answer. So initially, where is the cargo ship that are at the middle of the sea? So when they reach the River Bay, river compared to the seawater, seawater is denser, correct? River is less dense. So if they are less dense, supposedly any object that are in a less than liquid, they're supposed to sink more or float higher. They'll sink more because the river water is less than. So this is how you give the answer. Okay, then we have question 7. Question 7, diagram 7.1 shows a 1,500 kg van traveling at a speed of 15 meters per second collide with a 1,000 kg car traveling in opposite direction with a speed of 20 meters per second. After the collision, both vehicles get stuck and move together. So A1 define momentum. So momentum is what? The product of mass and velocity. Simple idea. You can write in terms of formula way, or you can write in sentences. Or formula way means you can write like this. Momentum equal mass times velocity. If you want to use formula way, memang you straight away write the quantity in full. You also cannot write like that only, provided you define P is what, M is what, V is what. State the principle involved in the collision. So the principle under this topic is principle of conservation of momentum lah. Next, they want you to calculate the velocity of the van and the car after the collision. So we back to the question first, okay, to get more information. So now these two vehicles is actually in a opposite direction. Very careful. So momentum is vector quantity, right? Of course, this is M1, this is M2, this is U1, U2. But later on, when you sub into the equation, right, you have to put a negative. Why? Opposite direction. You see the arrowhead is opposite. Or you can put negative for 15 also, no problem. But you have to put the negative. Now, next, from the question also, they say both vehicles get stuck and move together. So later on, means after bang, this one is before ma. So after, basically, normally the heavy one bang, the small already, they will push together, they will stuck together. So they have same velocity. So they want you to find this one. So based on principle of conservation of momentum, the general concept, you have total momentum M1 U1 plus M2 U2 before collision. This one must be equals to total momentum after collision M1 V1 plus M2 V2. So before must be the same as after. Before same as after, right? But in this context, your V1 and V2 is the same because they move together. So we call this as common velocity. And our formula used become M1 U1 plus M2 U2 equals to M1 plus M2 bracket V. So, and this is also called inelastic collision. Inelastic collision. So you just sub accordingly all the given value lah. Do you have M1? Yes. U1? Yes. M2? Yes. U2? You sub. But you need to be careful. You have to put negative. Then M1, M2 is the same again, which is this. Then can you find V? Yes. Yeah. So this is how you put in the formula, and you will at the end get V equals to 1 meter per second. Again, remember to write the unit meter per second. You just write 1, no answer. You forgot to put negative, also wrong answer. Next one. The jet engine of an airplane use the principle of conservation of momentum to produce a forward thrust. And table show 3 different jet engine, P, Q, and R, that have been used to move forward the airplane. So you have 3 types. So this question, right, is similar like the section B essay questions. It's just that section B, there will be more choice and also more expect. Okay, so we see what they want first. Based on table 1, state the suitable characteristic of the jet engine which can move the airplane with highest velocity. So you highlight the word highest velocity. And then bear in mind, later on when you give reason, you do not repeat the answer as in the statement, which is highest velocity. You can say move with an acceleration, all this. Okay, so they want you to talk about the size of the combustion chamber. So of course, normally at the end, they will ask you to choose which is the best jet engine. So together we have PQR. Then we look at the size of the chamber first. They have small and big. So you want to have big or small combustion. You want it to be more faster. Of course, you need big, right? Why you need a small combustion chamber? Yes. So basically, you already have the choice also because these two is out one. Agree? And then the next one, the question also asks about the opening, right? So the air intake have to be big, while the out ones should be small because you will come out with a higher speed. Yeah. So this is how you say a larger combustion chamber. Why? More fuel can be used or more combustion or more combustion occurs. Okay, explosion can occur more. Then size of opening of exhaust small. Get released at a high speed. Okay, okay. So you won't repeat the terms velocity. Notice. Therefore, you choose what? R. Okay, last question on structured will be similar like section C essay. So table 2 show 2 types of pots and its characteristic. First, what is the meaning of specific heat capacity? Okay, so we always use the standard formula Q equals to MC theta, right? Specific heat capacity is this little c. If you rearrange, you have C equals to Q over M theta. So whenever you define specific capacity, teacher always say you all need to have the important term. Q refer to what? Heat. M is the idea on 1 kg and this 1 degree Celsius. So in your whole definition, you must have all these terms. Like you miss out 1 kg, 1 degree Celsius cannot. So how you give the proper answer is actually the heat energy required to increase the temperature of 1 kg of substance by 1 degree Celsius. Okay, again, heat energy required to increase the temperature of 1 kg of substance by 1 degree Celsius. Okay, move on. Based on the table, state the characteristic of pot. If it is used to cook food at a faster rate, they want you to cook faster. And then give the reason for the suitability of each characteristic. So material of the pot, material of the handle. Back to the diagram. Now, if you want to cook faster, what happened to the specific heat capacity of the material? Remember the idea of this specific capacity. So if the material have higher, like clay, in this case, versus what? Copper, which has more. So the idea behind is if they are high, that means they take time to heat up. While it's small, it's actually take shorter time to cook, or you can heat up faster. In simple words, okay, heat up faster. Okay, because you just need a smaller quantity of energy to heat the object, to increase the temperature of 1 kg of substance by 1 degree Celsius. So obviously, the material-wise, we will use copper. Then in terms of the handle, polymer and clay handle, actually both also is insulator lah, but then polymer, they will even higher this specific capacity, so they can. The better one is polymer lah if over clay. Okay, material pot, copper, better heat conductors, or you can say small specific capacity. Then polymer, better thermal insulations, or heat up slowly. Therefore, you know again, then the mass of the pot, in terms of mass, you don't need to be heavy one, correct? So the mass of clay is 3.5, copper 2.5. So mass idea is like whether heavy or lighter. Also it's lighter lor, portable. Okay, C, calculations. The copper pot is heated up by the heating plate for power of 800 watt. Calculate the time taken to increase the temperature of the pot by 50 degrees Celsius. So for this case, the formula that we use in general is Q equals to MC theta. Then next thing is, I always tell students the heat supply is come from where? Like this context, the heat supply is come from the electric, whereby they have this heating plate, they use electric one. They have the idea of power. So electrical energy is actually power times time. So hence our formula become PT equals to MC theta. So you have P, then they want you to find the time. Do we have the mass of the copper pot? Yes, or just now from the front, 2.5. Do they give you the specific capacity of the copper pot? Also, they give you the value. Then the change in temperature is 50. So you just sub accordingly. But you rearrange the formula, we want T ma. So T equals to MC theta divided by power. Okay, so this is how you get it. Yeah, you will get the time as 60.94 seconds. Okay. Now, if you're not good in maths, you always rearrange the formula first, then you sub, then you won't like later on time or divide, you confuse because you follow the formula exactly. So we done with we have done with the structured questions. So we proceed with essay question. So for essay question section B, right, you have two questions, question 9 and question 10. And you basically choose one, okay? Choose one that you're more confident to answer. And the total mark is 20. So we go through the question together. Diagram 9.1 show two convex lens M and N, which are used by Ahmad to build an astronomical telescope. And the power for the lens M is 2.5 and N is 10. So first, what is the meaning of power? Okay, so the idea of power lens is not those power for the work done, all this, they didn't link this. This power is like, example, you see the things quite blur, right? You wear the spectacles. So some people, they need high power lens. So we always link the lens punya power with focal length. They focus even more or further, okay? So it's actually the reciprocals of focal length, or in formula, power is actually 1 over F. So reciprocal means 1 over something. Okay, so they already tell you this 2.5 diopter, and the unit for the power under lens is diopter, and then N is 10D. Okay, so we see what information they need later on. So explain how the power of lens can be estimated in laboratory. So to understand this idea, before we get the power, like say you link power with 1 over focal length. So actually, how do you get the focal length of the lens? So I try to sketch out the idea, then you'll have a better understanding. So in a setup in the lab, okay, or on a table, you arrange, what you need is, you need the screen. Okay, you need a screen. Then a screen is like any white paper, then you hold it lah. Okay, then you also need what? You need a lens with lens holder. Okay, so beautiful. Let me redraw. Then what you do is you face the lens towards the object we are at a distance. Example, you face it on a, this is a window also outside, you from far you can, like example, a big tree, okay, you see any object lah. So this is actually object. So since your object is at the far distance, right? So whenever you can see a clear object form on the screen, right? Okay, then the distance from the lens and the screen is actually the focal length of the lens. Okay, so after you arrange, so what you do is you basically move your lens. until you see a very sharp image, then you stop. So let's say until here. So what happened is actually the light basically from far when they're parallel, right? They will focus. From far, they will what? Focus on the screen. So this is actually the focus point as well. Understand? So you basically see a upside down tree, but must be clear image or sharp image. Clear. Okay. Then you measure the distance from the lens to the image. So this is the focal length. Okay. So again, if you are my student, I always teach you all a way how to remember the 6-ray diagram. So this is also K6 lah. Okay. Now let's see how you construct everything in a sentence. So when you get the focal length, then you proceed with how you get a power. But sometimes one new syllables they actually don't focus on power so much already. Their memo will directly ask you how to estimate the focal length of the lens. Yeah, so that's why teacher explained the idea. But then if they want power, you just add one more idea lah. Use formula calculate later on. So the convex lens aim or focus to a distant object. Then the screen is adjusted until a sharp image is formed on the screen. The distance between the screen and the lens is measured. The focal length is the distance between the screen and the lens. And lastly, calculate the power by using 1/f. Next, diagram 9.2 shows one arrangement of the lenses used by Ahmad to construct the simple astronomical telescope. You are asked to investigate the arrangement and the characteristic of the lens used by Ahmad construct the simple astronomical telescope in the table. Now, of course, a simple telescope will consist of two lenses. You have this lens that near your eye. This is called what lens? They are called eyepiece. And then this lens is facing like star, any far object, right? So we call this as objective lens. So under optical instrument from 4, you will actually learn two specific optical instrument, which is telescope and also microscope lah. So you are asked to explain the suitability of the arrangement of each characteristic of the lens and determine the arrangement which can produce a bright and sharp image at normal brightness. Okay, so the idea of this telescope okay, generally is kind of easier to get one. Also for your understanding, I always tell students if you want to know this concept easily or more, right? The easiest way is actually you know how to draw the ray diagram of the telescope and also microscope. Then you will learn both instrument easily. So the arrangement for telescope, like say you have two lenses, right? Objective lens, eyepiece. So generally, they will have the same position of the focus point of eyepiece and objective lens as well. So this is actually objective lens. This is actually eyepiece. So something special when you draw the ray diagram is you will the object like star, all this at infinity, right? So your object is basically at infinity. And where is your image former? Your image is basically formed right below the focus point. So this is your image. Then how you construct a simple ray diagram is from optical center with the image head. Can you draw a ray? Yes. So I show you using this, then you will get the answer easily, or else I tell you the answer, I read out, then you like confused. Okay, then object at the distance, the ray that you have also, they are parallel to each other. But then they will actually intersect at the same point where the image form. Okay, so the idea of this ray diagram is you actually combine any two ray diagram from the 6-ray diagram. Okay, then this first image is actually act as object for eyepiece. Then you draw a reference ray and then you make it dotted. Again, because you know that the image form and the optical center, you can draw a ray, right? it dotted because it just used as reference. Because we want to know what happened to the two blue color ray that coming up. Then finally, the two ray is parallel to this ray. But you extended, but when you extended that time, you make it dotted also. You basically finish the ray diagram for telescope. Now, if they come out as section C, they may ask you to draw one. Okay, so what you need to know is you need to know about the focal length for both lens. So if you were to look at what teacher draw, right? This is the focal length for objective lens. This is the focal length for eyepiece. So can you tell teacher the relationship? FO is more or less more, right? Okay, this one know already. Now, why you use telescope? Because you want high magnification. The formula for magnification is actually FO divided by FE. Much more longer focal length of objective lens will cause a high magnification, or vice versa. You have a shorter, then you have high magnification as well. Okay, so there must be more than one. Then you see what is the total distance between the lens. So this is mean by total distance. Total distance means from where to where? Here to here. Exactly, they are same point, right? That means they are the sum. Now you have the model. The model is for microscope. And then lastly, diameter of the lens. Of course, we want the lens to be bigger diameter. So once you know your choice is P, then you can get 6 out of 10 marks already. Teacher said, right? Because you say this, and then you say choose P, and then you repeat what is all this about again. So memang in your explanation, you memang follow on this one, okay, because they do not show any number. Then you just need to tell what is the reason behind it. So I hope that by construct this ray diagram, you'll have a better idea already. So longer focal length for FOY to produce ray inverted and smaller image. Okay, because from infinity, you form the object is K6, whereby again, you memang follow teacher's class, right? I will teach you the 6 ray diagram, but won't read. Okay, they memang have a fixed rhythm already one. Okay, then you have high magnifications. Why? Produce bigger image. Then the distance is FO plus FE, sharp image and normal adjustment. And then bigger diameter, more light can fall or pass through, then brighter image. So you say you choose P and then you repeat all the characteristic mentioned. Yeah, then you get 10 marks lah. Okay, move on. So section B always have 5 marks calculations. Okay, so the information given is an object is at 20 cm, then the focal length of the lens is 10 cm. Okay, so power of lens, just now teacher say P equals to 1 over F. Now, of course, when you use this formula, the focal length must be in meter. So therefore, you need to change the focal length into meter. So it's 0.11 meter lah. So you divide, then you get the answer, and then the power diopter. Then the image distance form. The image distance form, you need to use lens formula. So when you all use the formula for lens formula or this power, right? You all need to be alert about the focal length also. For convex lens, they are called converging lens also. Therefore, your focal length among positive. Let's say you solve other questions or they mention about concave lens. If the concave lens, then your focal length have to be negative. Then you careful lah. So whatever calculation you sub. If concave, you have to automatically alert yourself because the question will not show negative there one. So like this case, we still no need to worry. We want to find B here. Now, so for this question, because both is also in cm, you can remaining cm, but your final answer also in cm lah. So 1 over B equals to 1 over F minus 1 over U. Then you just sub law 1 over 10 minus 1 over 20. Then you inverse it at the end. V is how much? Then lastly, magnification formula. What is the formula for linear magnification? You can have M equals to V over U, image distance over object distance, or height of image or height object, but in this context, we'll use V and U lah, because we can get it already, or the image distance for part 2. Okay, so I show you all the answers straight away. So, yeah, they're basically same size, 1. Okay. Okay, question 10. So question 10 and question 9, you choose one, will do. Total mark is 20 from section B. Okay, so first, what is the function of rheostat? So generally, rheostat is used to control, adjust the current. So you can cause the current to be bigger or smaller by adjusting the rheostat. So how does generally it function is, you have this slider, correct? Not so when you move your slider left, right, you will cause the change in the length. So what is the relationship between length and resistance? They are directly proportional. Longer length, higher resistance. Shorter length, lower resistance. So hence the end result is, when the resistance, you see longer length, higher resistance, right? Higher resistance, then what is the end result for current? They will have lower current. So this is how you adjust the current. State one factor that affect the changes in the resistance. So this case is length. Okay, next one, how it work? So current from B, flow from B to C. Okay, so like say, that's why how do you all connect your terminal? Every time when you all use rheostat, right? They, of course, they do not like ammeter and also voltmeter have positive and negative, but you must always clip the crocodile wire on the upper and lower part when you do experiment in school, right? You cannot clip both on top like this, no, or both beneath, cannot. You clip on terminal A, then you have to clip on the other way around. So how does it work? After you clip the crocodile clip here, and here is the current will flow from this coil then across. So this is, if you clip on both A and P, then you will always pass through the whole length. So it's like no effect lah. Then next, the slider is moved to change the length of the wire. And then like teacher mentioned, all length is directly proportional to resistance, and length of wire is inversely proportional to current, or resistance is inversely proportional to current, and hence you're able to adjust the current. Yeah. Next one. Diagram 10.2 shows an electric kettle used to boil water. Table 4 shows the specification of 4 wires of the same diameter that can be used as a heating element. Keywords are heating element of the electric kettle. So you need to be focused on idea of heating element now. So you have these 4 wires, J, K, L, and M. You're required to determine the most suitable wire and explain a suitable based on the following aspect and give reasons of your choice. Now, I always tell students, under electricity, you have 2 different ideas. One is about heating element. And then another idea is you need to have like a good conductor, electrical conductor lah. So there are 2 different concepts. Heating element, what is your purpose? You want the heat, correct? You want more heat. So when you want more heat, you think about the resistance of the material. Should it be high or low? It should be high. But if I want the context of good conductor, then why it must be good electrical conductor? You want more current to flow, agree? Then you have to be low resistance. So these 2 ideas memang is opposite one. Okay, so you bear in mind, if heating element, we want high resistance now. Because a lot of times students always focus on this only. Resistance and current is inversely proportional. We want more current, more current. Of course, nothing wrong if it is a cable, if it is a transmission line, or all the wiring that connect your electrical device in house, understand? But then for heating element, memang we want more heat. That's why we have to have high resistance. Also, this one, you all need to be alert lah. So therefore, in terms of resistivity of the material, it should be high lah, correct? Okay. Next, For heating element, do you want high density or low density? We don't want the material to be heavy, what? All right. So therefore, low density is the best idea. These two amount too high. Then melting point should be high as well. Low oxidation rate. So it seems like you have the answer already. So the best choice seems to be what? M. So density of the wire is small y, lighter. Melting point high, the wire will not melt in high temperature. Oxidation rate is low, the wire can use for a longer time or will not get rust. Okay, will not get rust easily. That's why long lasting lah. High resistivity, more heat produced. Then you say I choose M because of all these factors again. So that's why you always remember, once you choose correctly, memang you automatically get 6 out of 10 if you know the format as well lah. Similarly, you do not know the format, you go and explain all the aspect one by one, then wrong. Then you see everything that got number, you see they didn't write number, right? Do they say the density of the wire is do they say the density of wire is 2,500? No, no number, understand? You just describe high or low, big or small. But then memang they already give you low, high, you follow. They memang give you those material that, example, they say use nichrome. So you memang write nichrome. Why? Because high resistance, something like that. Okay. But number wise, you only describe high or low. This is called format. This is understanding how to answer. And you memang focus on what? M only what? You talk about other wire, you didn't say that what? Next one should be calculations. So in section B, they always will have 5 marks question on calculations. So 3 identical bulbs labeled 6 volt 18 watt are connected as shown in diagram 10.3. Okay, they want you to calculate what? The resistance of one bulb, the total resistance in the circuit, and the total energy dissipated by the bulbs, all the bulbs in 2 minutes. Okay, so they want resistance of one bulb, total resistance. Okay, now each bulb is giving you 6 volt 18 watt. Although this is what it means. So this 6 volt is potential difference, 18 watt is power. So they want one bulb, A ma. Also they want you to find the resistance of one bulb. So you have V and P. So what is the formula you use? So you have 3 formula for power and 3 formula for electrical energy in this electricity topic, correct? So teacher always say, you know the 3 formula for electric current, you automatically know the formula for power as well. You have what? VIT, remember? Then V squared over RT, and then you have I squared RT. Then power is rate of energy E divided by time. So you cut all the T, you have the formula for power VI, V squared over R, and I squared R. So you have the idea of P, V, and then you want to find R. So which one? This one. So you have P equals to V squared over R. Then you rearrange R equals to V squared over P. Then you sub lah. You will have 6 squared divided by 18. Get the answer. So the resistance for each bulb is 2 ohm. Then next one, what they want? They ask you to calculate the total effective resistance of the circuit. So you need to know, is this circuit series circuit or parallel circuit law? If it is a parallel, remember you have the formula 1 over R equals to 1 over R1 plus 1 over R2. Yeah, remember you have R1, R2, R3, these 3 bulbs respectively. So for part B, you will have total R equals to, I normally will tell students, I will write in this way, then I inverse it. The same idea, you can use the 1 over R, nothing wrong. So you will get 3 over 2, right, inverse. So you get 1.5 log the total resistance. Okay, then next, they say the total energy dissipated in 2 minutes. E, the idea of E then. but then the time is 2 minutes. Now, it's 2 minutes. SI unit, no more, you change to second first. 2 times 60, 180. So you have the idea of T. You have the idea of total R, total V. You can use V square over RT, correct? Because now they say all bulbs, so that's why you use this formula. You want to use VIT, all this can, you need to find out what is the current first. Also can, but you just have more steps. So basically, those formula that teacher show you all just now, the 3 formula for electric current and also the 3 formula for power, right? You can use it, okay, if you know those quantity. So not necessarily like everyone have the same formula, but your final answer must be the same. So like this case, your total V, 6 square. Now you use 1.5 and not 2 because all bulb ma. And then times 180 lor. So by right, you should get 4320 and the unit is joule energy. Okay, so we see the answer scheme together. Hey, wait, just now did you make mistake? Oh, correct. I make mistake, I forgot to inverse, right? I straight away 3 divided by 2 ada. Okay. 2 divided by 3. So that's why 2 divided by 3 is 0.67. Okay, I make the slight mistake. Then only just now teacher say you can use E equals to V squared over RT. So we try out again. This V square is 6. By right, they're supposed to be same one. By right, we try out and see. Then the time is 180, right? 2 minutes. Okay, 120. Sorry. This is true. Yeah. Also, my one will have decimal point because I use this decimal point. So it's nothing wrong. They will accept one. Also, don't worry about that. Yes, we already done with section B essay. Now we have the last question on section C. Section C essay question is compulsory answer. You only have one question. So diagram 11.1 and 11.2 show magnet being pushed with the same speed into the wire coil which have the same diameter. Both are connected to the galvanometer. First, what is the meaning of electromagnetic induction? So they indeed will ask your definitions or the simple idea or knowledge. So electromagnetic induction is what? The production of EMF or induced current by cutting of magnetic flux, right? Or changing of magnetic flux. Okay, so you get this answer. Now, of course, some students may always like, teacher, how to remember so many definitions? So I always tell students, when you try the questions, you try to remember, and whenever you learn those topics, right, basically, they will, like every subtopic, you all will actually start with definitions, then formula, understand, and then later on, you have the application. So physics kind of direct, like the sequence is always like that. So it's good that when you learn that time, you try to memorize or remember. Then of course, when you do exercise, you recall back. And then when during near to SPM, you focus on certain questions. So you keep on seeing those definitions. So then end up you will help up in the definition part. Okay, move on. So they always want you all to tell the comparison one relationship. So what they want you to compare the number of magnet, the rate of cutting of magnetic flux, the angle of deflections, and later on, you tell the relationship between number of magnet and rate of cutting, density, and the magnitude of induced current. So indeed, this part is similar like structured question 5 and 6. You have a comparison idea. And even though this is compulsory answer, right? and teacher always say this part you must try to score 5 marks. It's like bonus for you. Even though you may not very clear with what is electromagnetic induction, this concept. Okay, so you just need to compare diagram only. So we see, you know where is magnet, you know what's magnet or not in the diagram? No, right? This is the magnet lah. So which one more? You just need to say this one more, 11.2. So number of magnet more. Of course, you need to write everything lah. You don't just say more in 11.2. Then if you have more magnet, the concept is this field will be more, right? The field produced by the magnet will be more compared to this one, example like this only. So once it move in and out from the solenoid, which one will cut more? Of course, this one will be cut more, agree? That's why more cutting, the deflection of galvanometer, obviously, this one is more also. Okay, so actually kind of direct lah, these questions. And the relationship is directly proportional or increase. Okay, so you see diagram 10.2 have more magnets. Then the cutting magnetic flux is 10.2 is higher or more. Okay, and the angle of deflection is 10.2. Actually, it's all 11.2 also. Yeah, the typo error in the schema. Okay, then last relationship, you say when the number of magnet increases, the magnetic flux have a higher density. Sorry, this one again, you must follow one. When the magnet is greater, that means the rate of cutting is more. Then when the magnetic flux increase, the current induced also more. Or you can use the idea of directly proportional for relationship in essay. You say the number of magnet is directly proportional to the rate of cutting of magnetic flux. Same go for C2. Acceptable. The magnetic flux is directly proportional. The density of magnetic flux is directly proportional to the induced current. Yeah. Then we proceed. Part D. Figure shows the structure of a direct current generator. So what the question want, they want you to explain the working principle of a direct current generator. Okay, so under electromagnetism, a lot of times students will actually confuse between generator versus the idea of motor. Okay, so how do you differentiate and not to be confused is you just look at the whole structure. If there is no battery, then it's referred to generator. Motor, you must have power supply, or simple lah. Normally, they will put a battery there. Okay, power supply lah, AC, DC. Okay, so this is indeed a DC generator. Why? Because you have this part, we call it as split ring commutator, or simple, they sometimes just say commutator itself. That's it. So this commutator enable the current come out from the external circuit is always in the same direction whenever you rotate the coil. So the ideal generator, where we see the ideal generator is in the power plant, right? So when, example, hydropower plant, water will fall, they will turn the turbine. The turbine will connect to this generator. So you will have the axles to turn this coil one. Then current is being generated. So when you turn, so that's why when you explain the working principle, simple idea, you must like focus on you rotate it clockwise and clockwise. You notice you rotate this thing like this way, I show you something like this is my paper. You move one side up, one side down. So you will notice the rotation. So is this rotation clockwise or anti-clockwise? Clockwise, right? So you mention this, you actually get the idea. So you say you rotate the coil clockwise. So and under the generator idea is under electromagnetic induction, more focused on the 4.2. So you say that it's a cutting of magnetic flux. You got another point again. Then the magnetic flux, the change in magnetic flux, induced EMF or induced current. Yeah, and the current flow through the commutator and causing the current flow is always in one direction. So these are some key points. And you want to add on is like you can mention the structure. Also, you later on you talk about the DC generator have what something like that. So a DC generator consists of what? Rectangular coil placed between the pole of a magnet. Then the coil is connected to external load via what? A carbon brush that touch the commutator slowly. Or you just can say the coil connect to the external load via carbon brush which touches the commutator. That's it. Then when the coil rotates clockwise, you see I mentioned already how it rotates clockwise just now. The coil cuts the magnetic flux and then induced EMF or induced current is produced. Then the resulting induced current will flow through the external load in one direction only. Yeah, because if two-way, then it's actually slip ring. So the structure will slightly different. If it is a AC generator, so you still have the coil, but then each one will have each. This is called slip rings. So then this is AC. This one will cause the current that connected outward later on, right? This external, the current will actually always changes one. Like first cycle is like this. Then later on the next cycle, right? The current will be opposite direction. Okay. So some idea for you all lah, the different. Okay, let's see the last part. So last part on this question, section C is problem solving questions. So diagram 11.4 showed a bicycle dynamo and the dynamo is connected to an electrical bulb and it's found that the bulb is dim. So using your physics knowledge, explain the modification can be carried out to increase the brightness of bulb. That's it, finish. So we see, do they give us more idea or not? No. So if they didn't tell you what to be modified, so you see what is given on the diagram. All these things may be help out like the knob, the rotation of the magnet. So your idea for this case is you want the bulb to be bright. And this is dynamo. So something special about dynamo, which are different from what you see on just now, the DC generator is DC generator coil is moved, right? Magnet is fixed. But then in this case, when you turn the dynamo, your magnet is turning. Magnet is moved. Okay, but your coil inside here, you see the coil is stay on, remain. Of course, if you want the bulb to be brighter, then you want to have what? More current being induced, right? So under this idea, you want to have more cut of magnetic flux. So in terms of magnet, you can say more magnets law or stronger magnet. In terms of coil, more coils. So of course, the reason is end result, you want to have more cutting of magnetic flux. Then in terms of rotation, you want to rotate more or less? Yes, also if you want to rotate more, or what happened to the size of knob? What do you think? You want to keep on turn, right? Then the knob size also smaller, so you turn more times. Yeah, so end up your induced current, the output or I is increases, causing the bulb to be bright. Or you turn the dynamo faster lah. Yeah, so let's see the answer together. Use a stronger magnet. So increase the rate of cutting magnetic flux. Okay, increase number of turn, cut more magnetic flux. So basically, both same answer. Sometimes they may only accept once, but depend. Okay, if certain reason memang is the same, they will accept more than one times. All right. Then coil made of metal of low resistance. Why low resistance? Produce more induced current. Use thicker wire, low resistance. Again, diameter of the knob is smaller. Magnet rotate more and increase the rate of cutting of magnetic flux. Okay, so if you want to have more idea, you can put in one for this section C essay question, and you no need to make a conclusion for this part of questions lah. Yeah, so that's why these questions depend. If you do not have concept, memang kind of hard for you to give marks, give the idea. But if you know the concept strongly, you see, like they are under electromagnetic induction. So they may more focus on the idea of more induced current, more cutting of magnetic flux, all this. Yeah. So try your best to really master each chapter so that you all really have a better understanding. Right? So we have been finished the whole paper 2 lah. Right. So hope to see you all soon. Okay. Yeah, if you're interested in all those questions that teacher explaining, you can always contact teachers and join teacher's class. Okay, thank you. Bye-bye.